This is the fifth and final part in our series about astrolabes. This part gives a rough outline of how astrolabes actually work. The Greeks knew that the Earth was roughly spherical, and it was fixed in the centre of the universe. They knew that the Sun travelled around the Earth every 24 hours. Well, not just the Sun, but also the Moon, the 5 planets, and all the fixed stars. They all go round the Earth every day. Well, that's almost true. Over the course of a single day, the Sun actually moves a little slower than the fixed stars. So the stars take about 4 minutes less time to do a complete revolution than the Sun. This means that over the course of a year, the Sun gradually alters its position with regards to the background stars. The circular path the Sun follows over the course of the year is tilted relative to the rotation of the fixed stars. At the spring equinox, the Sun will be lined up with the Earth's equator. Over the course of the next 3 months, the Sun moves so that in the northern hemisphere it gets higher in the sky. This continues until by the time of the summer solstice it is at the peak position. This track is called the ecliptic, and all the planets move along the same path, although at different speeds. From any position on the Earth, the sky's rotation is tilted relative to the horizon. So in order to work out where a particular planet is going to be, the tilt of the daily rotation of the sky must be added to the planet's motion along the ecliptic. Adding all these offsets in spherical geometry is quite hard. It would be easier if there was a way to construct a device to do it for us. Is there a good way to represent the spherical sky on, say, a flat piece of bronze? One obvious way to do that would be to project positions on the sphere onto a flat sheet. For example, if we draw an imaginary line from the South Pole through the point on the sphere and note where it hits the plane at the North Pole, then all the northern hemisphere appears within a circle. Whoever tried this would surely have been astounded to discover that any path that makes a circle on the sphere also makes a circle in this type of projection. Not only that, but when these circles meet, the angles on the flat projection are the same as those on the sphere. These two facts simplify the construction and make the resulting instrument much more useful. The front of the astrolabe is a model of the medieval universe. The base represents the fixed Earth, with the grid showing what you can see from your current location, and the rete represents the rotating sky, with the fixed stars and the location of the ecliptic. The Sun and the planets are always to be found on the ecliptic, with their exact location indicated by their zodiac position. There are a number of pieces of software that can help you in constructing astrolabes. For example, this website has a downloadable Java program that lets you select the components you want and the location, and it'll create a PostScript file that you can print to make a paper astrolabe. This has been the final part of our series about astrolabes. We hope you've enjoyed them. I've been using a custom astrolabe from the Rose Keep Etsy shop.